Welcome back, aliens. My name is Devin Reddy, and in this video, we'll talk about broadcasting in Numpy. Now, basically, when you talk about the arrays, we can perform different operations with it. And one of the operations is, let's say, you want to add two arrays, and that should be straightforward, right? So let's say I want to import, first of all, of course, this is a new notepad. So I will say Numpy. Of course, we need that. Now, once you have it, let's say I want to create an array. So I will say arr1, and in this array, I will be going with np.array. And let's say I want to create a one-dimensional array. So I will just specify 1, 2, 3. So let's say this is one array. And of course, I can just print it here just to see if this is getting created. And yeah, you got one array here. Now with this, I want to create the second array as well. So instead of just typing that way, I will just print it. And let me create one more array. So arr2. And this is np.array, and I will say, let's say 2, 3, 4. Okay, this is the second array. And now I want to print this one as well, just to see if both are coming correctly. And yeah, so you got the first array 1, 2, 3, second array is 2, 3, 4. And now I want to add it. How difficult that could be? So let's say I will say arr3, and we will just simply add them. So arr1 plus arr2, add, it works. You can see we got 3, 5, 7. How exactly this is working? So let's go back here, and we are talking about broadcasting. So basically, let's say we got two arrays, right? So you got arr1, which is your single dimensional array, and with the values 1, 2, 3. And the second one, which is arr2, which is your 2, 3, 4. Now, when you want to add this is straightforward, right? Because this array is 1 into 3, and this is also 1 into 3. So what I'm saying is we got one row and 3 columns in both the arrays. And when you want to add, logically, if you think, it's so simple. The first value will be added to the second value. So the resultant array will be 1 plus 2, which is 3, then 2 plus 3, which is 5, and 3 plus 4, which is 7. And you might be thinking why I'm explaining such a simple concept is because the moment you change these dimensions, there will be confusion, right? And we'll see those confusions at this in some time. But this is how it adds, right? So when you add this to value, this is what you get, and it's so simple. But let's create some issues here. So what issues I'm talking about? So let's go back here, and before the issue, I want to show you one more thing. It's not just two arrays. You can even add a scalar value, let's say 4. So now this 4 is getting added to this array. Now logically, again, there are certain rules when you add them, but logically, if you think, what should happen? To understand this, let's go back here. And now what we are saying is we got the same array here, this one, and this is getting added with 4. Now, what do you think will be happening here? Now, first of all, this is an array, which is 1, 2, 3, 3 columns and 1 row. We are adding that with 4. Technically, this should not work is because 4 is a scalar value. This is an array. But then Numpy says, hey, don't worry. If you just add it with 4, what I will do behind the scene is I will take this 4 and I will add with each element. So this 4 will get added with 1, which will become 5. Then 4 will become getting added to the 2, which will become 6. And then 4 and 3 is 7. This is what I'm expecting in the output. Let's see. And we got the same value. So nothing complex at this point. But let's create some issues. Not exactly an issue, but let's say I got an array here, which is arr1. I will just retype it so that it will be there with us. And then let me create the second array here itself. So I will say arr2, which was normal single dimensional array before, but now I want to change it. So I will say numpy np.array. And instead of creating a single dimensional array, let me go with multi-dimensional array or two-dimensional array. So here, let's say I want 3 rows, not 1 row, 3 rows. And each row, let's say, only has one element or one value. So one column, basically. So let's say we got this value. Now, if you try to imagine this, if I try to print it, first of all, arr2, and see how it looks like. Now, since this is two-dimensional array, I forgot to mention one extra bracket, run, and see how it looks like. This is a single dimensional array, and this is a two-dimensional array. So 3 rows and 1 column. So if you want to imagine this in the diagram here, so let's remove all. And now I want to add this. So we got the second array, which is arr2, and this is multidimensional, or we have 3 rows. So I will specify the values here, 2, 4, 6. Now, if you look this is 1 into 3, and this is 3 into 1. How will you add this value? Logically, it should not work, is because there are different dimensions. But let's see what Numpy says. Numpy says, hold my beer. Let's see. Enter. It works. And this, my friend, is called broadcasting. But what is happening here? And this is where you have to understand the rules of broadcasting. There are multiple rules, but then let's think in logical sense. Now, what happens behind the scene is, let's imagine with the animation. So you got an array 1, which is 1 to 3, which is single dimensional array, 1 into 3, right? And the second one is 3 into 1, 2-dimensional array. Now, if you want to add them, so if you have to adjust it, how will you do it? So what if you can make the first array something like this, where you have 1 to 3, 1 to 3, 1 to 3, where you have 3 rows and 3 columns. So you are just copying the values. Now, if you imagine this is 3 into 3, the first one, second one is 3 into 1. What if you can also change the second one and make it 3 into 3 by copying the columns? So 2, 2, 2, 4, 4, 4, 6 is 6. So what you got in turn is 1, 2, 3. This is the first one, which is ARR1. And now you got the second one, which is ARR2, which is 2, 2, 2, 4, 4, 4, and 6, 6, 6. And now, simple to add. So this becomes 3, 4, 5, 5, 6, 7, 7, 8, 9. And let's see, is the same value we got? And that's right, you got the same values. So this is what is happening. This is broadcasting. So that means it doesn't matter what type of dimension you give, NumPy will adjust it. Is it? Not exactly. Let's try another example where you will get the error. So let's try with other values. So I got the values here. ARR1, this time is 1 to 3, it's the same thing. ARR2, the same, different values, but you can see this single dimensional. So both are single dimensional. There should be some adjustment. What do you think? Will it work? Logically, if you think, so if you see in the image here, the first one is single dimensional but 3 columns. The second one is 4 columns. Even if NumPy says, let me try, how NumPy will do it? If you say enter and if you try to add this is what NumPy will say. NumPy will say the operands could not be broadcast together with the shape, this shape. So what are the rules? How do we know when NumPy will do it and when NumPy will not do it? The first rule is the shape needs to match. So in the earlier case when you tried, here, both have the same shape. If you see, both are 1 into 3. In fact, when we have written this here, this is a shape which we got. Behind this it is 1 into 3. So that's the first one. Next, if the shape is not same, in that case, NumPy will try to broadcast. But what are the rules? Of course, we have talked about the first one. The dimension should be same. Second, if the dimension is not same, then we have to go from the right hand side. So if you see these two arrays and if you see the size, the right hand side will start from the right to left. And at least one of this should be 1. In that case, if it is 1, then NumPy will try the broadcasting. So let's say we got this example. Instead of typing, I'm just saving some time. So you can see we got an array here. Now this is a 2-dimensional array here, the first one. Second one is single dimensional. So if you try to imagine this, the ARR1 is 1, 2, 3, 4, 5, 6. The ARR2 is 2, 2, 2. Now here what will happen? This is 2 into 3 and this is 1 into 3. So let's try to add it and it works. But how it is working? So you can see the first one is 2, which is 2 rows and 3 columns. So 2-dimensional. The second one is single dimensional and this is working. So logically, if you think what is happening. So what we have talked about is in broadcasting, one of the dimensions should be 1. And if you see the last dimension is not 1, but if you see this one is 1, I mean the first dimension here for the second array. If this is 1, it will try to adjust. So what it will do is it will make the second array something like this, 2, 2, 2, 2, 2, 2 to make it 2 into 3. Now this one and this one got the same dimension, so it will simply add it. So 1 will be added with 2, which will make it 3, and that's why you can see we got 3 here. Then this 4 is going to be added with this 2, and that's why you can see we got 6. So that's how basically broadcasting works. It tries based on the rules. Okay, and don't try to remember the rules. Think logically. If you think it can adjust, it will adjust. So let's take one more example just to make the concept clear. If you see the first array here, this is 3 into 2. So we got 3 rows and 2 columns, right? Something like this. The second one is 1 into 3, which is 1 row and 3 columns. Can you try to adjust here? So even if you try to replicate the second one as 2, 2, 2, 2, 2, 2, still we're not able to match it. So there's no possibility where the second array can match with the first one. And that's why if you try to do this, it will give you an error. So yeah, that's how basically you have to think logically. It's not just about the rules, but logically if you think, this will make sense. So yeah, I hope you got the idea how broadcasting is working. See you in the next video. Bye-bye.